Hey science fans, did you ever imagine that we might detect cancer from space one day? It sounds like science fiction, but it's getting closer to reality. We're talking about using satellites to spot cancer early, way before traditional methods can. How is that even possible? Well, it all starts with a gas called ethylene. This gas is a natural byproduct of our bodies. However, cancer cells release a lot more ethylene than healthy cells. Think of it as a distress signal that we can now detect from hundreds of miles above Earth. Okay, so what's the deal with ethylene? Our bodies produce it naturally, but things get interesting when we experience something called oxidative stress. This happens when unstable molecules, called free radicals, build up in our system. Oxidative stress is linked to many diseases, including cancer. When cancer cells grow, they pump out extra ethylene. Scientists have found high ethylene levels in people with liver disease, lung cancer, and breast cancer. Now, how do we actually see this ethylene from space? We use special satellites equipped with hyperspectral imaging technology. Think of it as a really powerful camera that can see way beyond the colors we can see. These satellites can detect tiny traces of ethylene in the atmosphere. Then, artificial intelligence, AI, comes into play. AI algorithms analyze the ethylene data and cross-reference it with cancer registries and air quality indexes to pinpoint potential hotspots. Section 4. From Space to Earth, a plan of action. So, imagine this. Satellites constantly monitor ethylene levels worldwide. If a region shows unusually high levels, it triggers a sort of early warning system. Then what? That's where ground-based validation comes in. Health officials could use portable breathalyzers to test people in the flagged area. Breath tests are already used to diagnose some diseases. Early detection could mean more effective treatment, potentially saving countless lives. Section 5. Overcoming the hurdles. Of course, there are challenges. Ethylene doesn't hang around in the atmosphere for very long. Also, industrial activities can release ethylene too. We don't want any false alarms. The solution? We can use swarms of low-orbit nanosatellites for more frequent monitoring. Plus, AI algorithms can filter out industrial ethylene emissions, making sure we're focused on the ethylene coming from people. Section 6. The future is now. This technology has incredible potential. Imagine cancer risk maps, similar to weather forecasts, that could tell you if you live in a high-risk area. Or think about space-based clinical trials that could track the effectiveness of new cancer treatments on a global scale. We could even have wearable ethylene detectors that sync with the satellites, giving us real-time feedback on our health. The possibilities are truly out of this world. Section 7. A giant leap for public health. So, there you have it. Detecting cancer from space may sound like something out of Star Trek, but with ethylene as our guide and the power of satellite technology, we're on the verge of a revolution in cancer prevention. Think about it. Early detection, targeted screening programs, and even monitoring the impact of pollution on our health. It's not just about cancer, it's about creating a healthier future for everyone. And that, my friends, is science at its best.